Hey guys, so today we are going to talk about ratio tables. So far we're talking about talked about ratios, which are comparison of two numbers that have the same labels. Then we've talked about rates, which are the comparison of two numbers with different labels. And now we're going to use tables to help us organize our information. So let's get a good definition to a ratio table. So a ratio table is a table, so that's the way we organize information, where all of the columns, so those are vertical, have ratios with the same value. You might be going, what? Remember, when we get to our examples, they kind of make sense. And so basically, if they all have the same ratio, they're not going to be all the same numbers. What we have are equivalent ratios. So equivalent ratios are ratios that simplify to equal the same ratio. So if you remember back when we were talking about ratios in class, and we had the 3 triangles and the 4 squares, and then I added another 3 triangles and another 4 squares. So when we did the original ratio, we had 3 to 4, but when I added on that other group, that was 6 triangles to 4, or to 8 squares, and then we simplified and it went back to 3 to 4. That's kind of what we're talking about, that 3/4 and the 6/8 were called equivalent ratios. All right, so I'm going to give you a little recipe from my mama. So this is Mom's famous punch recipe. Okay, so this is kind of a little bit of a story here. So my mom she liked to entertain, and so she always had some ingredients on hand in case people came over, and she would make a punch. Now the punch was super simple, but everybody loved it. It involved juice and involved soda. So sometimes the soda might have been like 7-Up or ginger ale. You didn't want to use something like Coke or root beer because they have too much flavor. You wanted something bubbly and maybe some citrus, maybe ginger ale even, just plain old soda water, depending on your juice. And then it could be any kind of juice. And so this recipe people loved. They're like, you've got to tell me how you made this. And it was so simple. So she used 2 basic ingredients. She used soda of some sort, and then she used juice of some sort. So you could change it up any way you liked. And if it was, just a small gathering, she would need 1 soda. So let's say, could be small, 1 cup, 1 quart, 1 pint, 1 gallon, whatever it was. But if she needed to make more, she would just say, well, I'm going to do 2 cups of soda. Oh, wait a second, I put the wrong number in here. Let me fix that. Dang. This is what needs to change. It wasn't 2, it was 3. It's been such a long time since I had my mama soda. And then it would be for 2, let's say, cups of soda, it would take 6 cups of juice, okay? And then if we had like a big, huge party, we might have 3 cups 3 pints, and then we would have 9 over here. So I'm going to actually cut it down just to this. Make it a little bit neater and smaller, okay? So what this is illustrating is that, let me change my colors. I'm tired of using the same ones all the time. Let's go to a nice purpley. So let's get rid of this guy. And we would get 1/3 would be the same as 2 6. And you're like, well, those aren't the same numbers. But if we simplify, they're both even. We can divide out of 2. They equal 1/3. And this is equal to 3/9. And you say, well, again, those aren't the right numbers there, Rosner. You're losing it. Well, yeah, that's probably true. These both can be divided by 3. And that gives me 1/3. So basically what I've made are equivalent ratios inside my ratio table because they all reduce down to the same fraction of 1/3. So we use ratio tables to make values larger. Like in my case, I made my recipe larger, or make them smaller. So basically what we're going to do is to create the numbers. We're not going to be given a table with all the numbers in it. We're going to be given some of the numbers, and we have to figure out the mystery numbers. Okay? So we've got 2 examples. The first one, we've got a table of values we're going to be working with, but I'm going to give you a background on it. So we have a patient receives 1 liter of IV fluids IV standing for intravenous, every 8 hours. At that rate, let's see, so we have liters in time, so yeah, that makes sense. It's a rate, and a rate, remember, is a ratio, just different labels. At that rate, find how many hours it will take, oh, that was my tummy, to receive 4 liters of IV fluids. Okay, so here's the cool thing. When we draw our table, we're going to do the work in it. So we don't have to do it outside because it's pretty easy math. So our table is going to have IV fluids and it's going to be in liters, and then we have time, and that's going to be in hours. So the original problem talked about 1 liter every 8 hours. So those are the 2 numbers that I'm going to put into my table. And then it mentioned find how many hours it will take to receive 4 liters of IV fluids. So the 4's got to go on the top with the other fluids. So now what I have to do is think, how do I get 1 to become 4? Well, 1 times 4 is 4. So I'm going to do that to the 8, multiply it by 4, and 4 times 8 is 32. So we would conclude it takes 32 hours for a patient to receive 4 liters of IV fluids. Okay, so pretty cool. It's all controlled in that little package. I like that. All right. Oh, this is a little seasonal for us. I'll be making not so much jam, but definitely cranberry sauce. So to make cranberry jam, I'm not sure if I'd want cranberry jam. I don't know. You need 12 cups of sugar for every 16 cups of cranberries. It's amazing how much sugar you put into cranberries, real cranberries, in order to make cranberry sauce, and it still tastes tart. Find the amount of sugar needed to make 4 cups of oh, I said that wrong. You can't make that, sorry. Needed. Try that again. For 4 cups of cranberries. My head was going ahead and wasn't paying attention to what I was supposed to be writing. Okay, so let's see. We're going to talk about sugar, which is measured in cups. And we're going to have cranberries, which are also going to be measured in cups. And let's see, in the beginning what it talked about was 12 cups of sugar and then 16 cups of cranberries. So we're going to put them 12 cups of sugar, 16 cups of cranberries. Okay. Now, I'm going to introduce you to something that sometimes is a bit annoying. Sometimes your book is going to give you a table and it's going to have 3 columns in it. And sometimes, though, you're going to go, well, I'm not sure why I need 3 columns. And sometimes you don't. So sometimes it's there, and sometimes you don't need all 3 of them. So this one has 3, but we're actually going to go straight to the answer, I think, on this one. And then we had 4 cups of cranberries. So maybe a smaller crowd is coming. So the question we have is, can I get, this time notice it was on the bottom, from 16 to 4. Now it's smaller, so that means I'm using division. And I'm going to divide by 4. So 16 divided by 4 is 4. So that means that's the same thing I have to do up here. I'm going to divide 12 by 4, and that gives me 3. So my conclusion would be 3 cups of sugar are needed cups of cranberries. Alrighty. That's making me want to get hungry for Thanksgiving. Alright guys, I'll talk to you later. This will be due and we'll talk more about it when we come back from break. Bye now.